Hello and welcome to part 4 of my web application series. Previously, we set up SQLC and ran a Postgres database in a Docker container. In this video, we will connect our Go application to the database, generate hash passwords and UUIDs, and finally insert new user data into the database. In the user registration controller, after validation, we need to check if the given email address already exists. To do this, we need to create a query. This query will find the record with the given email address and return a boolean. If the email exists, we should get true, and if it doesn't, we'll get false. Next, we need to establish a connection between our Go code and the database. For that, I'm going to create a connect.go file, define database credentials variables, and create a connect function to be able to call later on. The connect function will have pgxcon and context parameters. In this function, we define a context background as ctx and call the pgxconnect method. In the pgxconnect method, we need to pass the ctx and the Postgres connection link, including our credentials. For simplicity, I set the SSL mode to disable. If you need extra security, you can change this. The next step is to handle possible errors and simply return the connection along with the context. Since we started this project from scratch, our mod file doesn't have the database driver. To fix this, we simply run the go get command followed by the GitHub link. Add this package to our mod file. Now that the database driver is added to the mod file, I can add my credentials to the Postgres connection link. Next, I'm going to create the query.go file to have a helper for my queries. For the email address exists query, I create a helper named isEmailExist with a single string parameter and return a boolean and an error type. In the function's body, we need to connect to the database and run the query. We can now call the connect function, which was created in the connect.go file, to get the connection and context. Always remember to close the database right before exiting the function. To call the SQLC queries, we need to create a new SQLC connection. To do this, we create a function in the connect.go file and name it SQLC. This function will receive the pgxcon as its parameter and return the SQLC queries type. Now we can go back to the query.go file and finish it. IsEmailExist function requires a context and the email address. Finally, we can go back to our registration controller and use this helper. This function will return a boolean and an error, which we need to handle. And for our test, we can print the result. At this stage, we need to create a .env file to store our database credentials and pass them to the connect function we created earlier. Reading a file or .env file is fairly easy, but for simplicity, I'm going to use go.env package by running the go get command. After adding it to our mod file, we can call it in our init function to make sure it fetches our credentials before any other function runs. After that, we can assign those credentials to our variables. Since our .env file isn't in the same directory as our connect.go file, we need to specify the path to the load function. Now we can do a quick test to verify that the email address doesn't exist in the database. Before we go any further, we must handle validation properly. First, we're going to remove the debug prints and create an if statement. If the email and password isn't valid, we simply redirect the user to the register page and return from the controller to avoid any further code execution. To redirect the page, we need to specify the HTTP status code. I use status cother, which is the built-in constant with the value of 303. The difference between status cother and move permanently or temporary redirect or permanent redirect is that using 303 cother ensure that the redirect uses the default method, which is get, while others use the latest requested method, which is post in this case. Now when we enter incorrect credentials, we get redirected to the register page. We can also confirm this by checking the browser's network tab, which shows the status code 303 and a redirect with the get method to the register page. To complete the registration controller, we have two more steps: hash the password and insert the credentials into the database. Hashing a password involves converting the string into a fixed length string of characters that is unreadable using a special algorithm. This technique makes it difficult for anyone to reverse the string back to the original password. Fortunately, in Golang, we have a built-in package that does this efficiently. You may wonder what will happen to the users who set the exact same password. To avoid having duplicated hashes, we use a salting technique. Salting involves adding a unique and random string to each password before hashing it. In Golang, both salting and hashing are handled by generate_from_password function from the bcrypt package. In this function, we need to pass the plain password and set the cost for the hashing algorithm. If you set the cost to maximum, you will get the strongest hash password, which takes more calculation time compared to the default or minimum cost. Now we can create our insert query. This is a normal SQL query where we just need to pass the email and password of the new user. Additionally, we need a UUID for each user, so we need to update our table and modify the SQL query accordingly. To generate a UUID, we need to define the set of characters we want to use. I'm using a list of runes to store these characters. The length of the UUID may vary depending on the use case. For this reason, I need to pass the desired size of the UUID to this function. First, I'm going to create the random string list and get the maximum length of our characters set in the max variable. Then in the loop, we can use the rand package to get the random integer, which will be used as the index number, and finally push the index value to the random string variable. At the end, we're going to return the runes as a string. Now we can easily use the getUUID function to generate a new UUID for our user with a size of 6. Now it's time to work on the last part of the registration controller, which is inserting the data into the database. We can create a function with the same name as the SQL query for better understanding. To know what type we need for the parameters, we need to generate SQL and check the queries.go file. The parameter we need to accept is insert new user params, so we can set it as the parameter and return an error. Like other query helper functions, we need to connect to the database and execute the SQL query. We can go back to our controller, call the insert new user function, and pass the user's credentials. Now it's time to test. I'm going to add the dummy email and password and submit it. Now that we get a blank page, we know that we have reached the end of the registration controller and no error has appeared. To confirm this, I'm going to re-register the same email address, and we should see an error message stating that this email address already exists. And last thing, I would like to redirect the successful registration to the login page, so the user need to log in after registration. This flow allows us to send an activation email to the user and filter out all those spam bots. That's all for this video, and I will see you in the next one. As always, thanks for watching.